Welcome all. So in this video lecture we are going to discuss the momentum formulation of Dirac equation. Let me write the name of the topic for you. Momentum formulation of Dirac equation. So for the notation part, let me tell you, P mu is, and there is momentum for vector P1, P2, P3, P4, which is also can be seen as Px, Py, Pz, IE by C. IE by C is nothing but P4, or you can also write it as Pk, P4, where Pk is equal to P1 to 3. K runs from 1 to 3, and this one runs from 1 to 3, 4. Okay. Now you know the Dirac equation. Hd of psi is equal to E psi, where Hd is Dirac Hamiltonian, which is C alpha dot T plus of beta m naught C square acting on psi is equal to E psi. I'm using the curly bracket because I don't want you to confuse between this C and this bracket. This is C, this is bracket. Okay, this is C, this is not a bracket, and this is the curly bracket. Now this alpha dot P, you can also write it as, this alpha dot P can be also written as alpha x px if you multiply alpha y py plus alpha z and pz. Okay, or you can write it as summation k equals to 1 to 3 alpha k pk, or you can, if you are using the summation convention, you can drop the summation simply, because if any indices is repeated, the summation is by itself implied, it is self-evident. You can just write it as alpha k pk. All these three things means the same. Okay, so we can replace this alpha dot p by this alpha k pk. Let me do it for you. C times alpha k pk plus of beta m naught of C square acting on psi is giving you E of psi. Nice. Now it is a usual practice in relativistic quantum mechanics. Whenever you see alpha k, you try to change this in gamma k. How you do that? You know that minus of I beta of alpha k is equals to gamma k. This relation you know. Okay, minus I beta alpha k is equals to gamma of k. So to make it minus I beta alpha k, you just multiply the whole equation by minus I beta. Let me do it. So minus of I beta, this term is multiplied by minus of I beta, so you will have C times minus of I beta alpha k times of pk plus of plus or minus, because minus I beta is multiplied, minus I beta beta m naught C square, whole thing acting on psi is giving you, also in RHS you will multiply by minus I beta into E of psi. Okay, so what's next? Just replace all these things with the respective values. This is nothing but gamma 4 beta square is equals to 1, and what else? This beta can be written as gamma 4. So after replacing these with this values, you will have 3 times of gamma 4, gamma k. It is gamma k, it is not gamma 4, it is gamma k. So C times gamma k pk minus I times beta square is 1 m naught C square operating on psi, giving you minus I gamma 4 E into psi. Nice. Can we take anything common? Yes, we can take C common. So on taking C common, you get C times alpha gamma k pk minus of I m naught C psi, giving you minus of I gamma 4 E of psi. So now you can bring that C to the other side. So you will have gamma k pk minus of I m naught C psi is equals to minus I E by C. Now you will start to see something. Let's see, what do you see? Okay, so this is nothing but P4. This is minus P4 times gamma 4 psi, because I E by C is equals to P4. Okay, so you can club these two. How? You can change the emphasis to mu, and I've told you that mu runs from 1 to 4. So first let me bring that to this side. It is P4 gamma 4 psi minus I m naught C psi is equals to 0. So these two are the same thing. You can write this P4 gamma 4 also as gamma 4 P4, no difference. So see, you can use the mu, gamma mu, P mu minus of I am not C into psi equals to 0. Now again you can use our beloved slash operator. It looks better like this. This is the slash operator. Minus of I am not C psi equals to 0. So this is the Dirac momentum formulation of Dirac equation. Okay, that's all for today. Thank you.